Welcome back to this course. Alright, so today we'll be looking at past questions. Okay, past questions from exams like the SSCE, the JAMB. Okay, so let's see questions that are related to the topic which you just did. Okay, so it's going to be like that for every single chapter, and so you can, for every chapter, see what is actually expected of you as a student sitting for these exams. We have a couple of problems here, so I would advise you pause the video at some point and try to solve them first, and then come back to see how we get to solve them, see if you're actually very correct, and to be sure that you grab the concepts of solving these kind of questions in preparations for the exams. So for the fourth question, for dimension of electromotive force, we have electromotive force equal to work over charge. Alright, work over charge, just in case you want to solve them on your own. For electromotive force, the formula for EMF, okay, work over charge, and charge is equal to current. Charge is equal to current times time. I'm sure we know what work is. Then we have momentum to be mass times velocity. Okay, so with these formulas now you can solve question 4 and question 8. Alright, so you can take a minute, get to solve them on your own, and then come back to continue the video. The first question is asking for the dimension of power. So we know power is equal to work over time. We know that work is force times distance, so we have force times distance over time. Now the formula for force is kilogram meter per second squared, because force itself is mass times acceleration. Okay, so we have the kilogram for the mass, then meters per second square for acceleration, while distance is meters and time is in seconds. So if we simplify this, okay, this S can be represented as S raised to the power minus 1 above here. So if we move this upwards, we're going to have kilogram meter per second squared, okay, per second times m. So this will now finally give us, of course, minus 2 minus 1 is equal to minus 3. So we're going to have kilogram meter squared, meters times meters, and then s raised to the power minus 3, s raised to the power minus 2 times s raised to the power minus 1, which is this one. We're going to have this. So this is the formula for power. Now if we need to find the dimension from here, of course, for kilogram we have capital letter M, for meters we have capital letter L and is meter squared, so capital letter L squared. For seconds we have capital letter T raised to the power minus 3. So the second question says which of the following unit is equivalent to the watt. Of course, we know the watt is the unit for power, so our answer we have already found here, kilogram meter squared per second cube. So the answer there is B. So for number 3 we have the SI unit of power is A newtons, B pascal, C watts, D joules. Of course we know the SI unit for power is watts, so our answer is C. Okay, so we move on to the fourth question. For the fourth question we have the dimension for electromotive force is, so we need to find what that is. We have EMF to be equal to work times charge. So work is force times distance, charge is current times time. So force times distance gives us kilogram meters per second square times meters all over amps times second. Okay, so if we convert this to its dimensions, we have work to be ml squared T raised to the power minus 2, and we have amps seconds to be IT. Okay, so if we move on, we'll find out that we have ml squared t raised to the power minus 2 raised to the power minus 1. Okay, of course this t here, this t down here comes up to become t raised to the power minus 1, so we have t raised to the power minus 2 minus 1. Then I comes up to be minus 1. So if you simplify this, we have ml squared t raised to the power minus 3 I raised to the power minus 1. Alright, so you can see that that is not difficult at all. Alright, so we move on to the fifth question, which says which of the following units is derived. Alright, we have A kilogram, B meters, C Kelvin, D newtons. Okay, and we know from our table of SI units and derived units that D is the derived unit, which is newtons. Newtons is derived. Okay, move on to number 6. Which of the following statements about mass and weight are correct? 1. Weight is the force of gravity on a body. 2. The mass of a body is the quantity of matter in it. 3. The weight of a body is greatest at the equator. 4. The mass of the body is greatest at the poles. Alright, if we look through, we know that 1 is correct. Weight is the force of gravity on the body. 2. The mass of a body is the quantity of matter in it. Those 2 are correct. So we check A, we have 1 and 2 only. B, 1 and 3 only. C, 2 and 4 only. D, 3 and 4 only. So the correct answer is A, 1 and 2 only. Okay, so we move on to the 7th one. We have force with units newtons. We have torque with units newton per meter. We have current with amps and power with watts. Which of the above are the correct SI units of the quantities indicated? Okay, so if we look at it, we know that the SI unit for force is obviously newtons. For torque is not newton per meter. Torque is newton meter. Okay, we might not know what torque is yet, but we'll visit it in a future course. But torque is newton meters. Current is actually amps and power is watts. So even if you don't have an understanding of what torque is, if you look through, you would know that at least you're sure force is correct, current is correct, and power is correct. So you now go armed with that to look at the options you have. So we have 1 and 2 only. Okay, we have 1 and 3 only. We have 1, 2, 3 only. And we have 1, 3, 4 only. So obviously from these combinations it has to be 1, 3, 4 only, because you're sure of 1, 3, 4, but you don't really know about torque, so you can be sure that it's 1, 3, 4 only. Now let's move on to the 8th question, the dimension of momentum. Okay, we have to find that. We know momentum is mass times velocity, so of course the dimension for mass is capital letter M, while that for velocity is LT raised to the power minus 1. So if we multiply that, we have MLT raised to the power minus 1. Okay, so for this first chapter, units and measurements, we don't have a lot of questions from this chapter coming out in JAM, WAEC and all that. Okay, but then, okay, I didn't say this to discourage you from trying out questions related to this, because you can't tell in your own exam they can decide to bring out a couple of questions from this chapter. Okay, but then you can also get exercises from other sources to keep trying and expanding your ability to tackle questions on this chapter.